So this problem, number 7, involves using a graphing calculator. Let's look through the problem first. So it says, Mr. Bean looks over the edge of the observation deck from the CN Tower, and that's in Seattle. Anybody ever been there? His glasses fall off. Bummer. The table shows the height from the ground of his glasses over time. Graph the data with a friendly window, and then you're supposed to put in the window information over here, X-min, etc. Here's the data. Then the questions say, Mr. Bean thinks a linear model would represent the data the best. He is wrong. Explain why he's wrong. What model would be more appropriate? Then part B says, use that regression to write an equation. And then use that model to predict the height of his glasses at 7 seconds. Then find the time at which his glasses will be 1,600 feet in the air. And then when will his glasses smash into the ground? And then the last question is, what does the y-intercept represent? Okay, so our first step here is to get the points plotted into our calculator. So I'm going to bring in my graphing calculator. And to right now, in my graphing calculator here, actually, let me use it. There, I think that's better. Okay, so I need to, right now, there's an equation in there. So I hit the y equals, it came up. So I'm going to clear that out. Looks like the plot 1 is already shaded on. I could shade it off, but we're going to come back and turn it on anyway. So I'm going to just leave that on. So stat edit is where I need to go to stat edit. And I've already put in the data. So if there was already data there, you would go up here and you'd hit clear and hit enter and then enter it in, or you could even just type over the top of it. Anyway, just make sure that all your X's and your Y's are in there, and then double check, make sure they're accurate. Oh, guess what? They're not. So for some reason I had the 0 through 10. Let me put these in then. 18, 21, down, 1757, 1565, 1245, 797, and 221. Okay, so now all my data is in there, and I want to look at it in the graph window. So under second y equals, takes me to this stat plot, and yours might not be turned on yet. So anyway, mine was, remember? So anyway, to go into plot 1, I'd hit enter, and then turn the plot on. The rest of this is what it will be most of the time. So it'll be type. The type I want is a stat plot, or scatter plot, I mean. And then the two lists most all the time are going to be L1 and L2. So L1, L2, and then a little square dot is fine for me. So I'm happy with the way it is. And the next thing I do before I hit graph is I'm going to go into the window, and I can see what my data are. Remember now this thing is falling. 10 seconds later, it still is up in the air. I think that looks good, actually, 0 to 16, which was what was in my window to begin with. I think I'm going to keep it there. 0 to 16 sounds good. Then down here for the y values, we want to know when is it going to hit the ground. So to make a little extra room, I'm going to go negative 200. So I'll have some room at the bottom of the graph. So it won't get in the way of the numbers and stuff. And then the high point, I know that the glasses aren't going to go up any higher. I'm going to go with a 1900. So it starts at 1821. I know it's not going to be up that much higher. And for the scale, I don't know, 500. Okay. So now I think, I hope, I'm going to have some points. There they are. All right. So it should look to you guys like something. I mean, it's kind of almost like a straight line, but if you look at this first one, and remember it said it's not linear. So if it's not linear, what's the shape of that? It's part of a parabola, looks like. And so I think it's going to be a quadratic. So that's what, so I guess actually before we go on to answer part A, let's look back here at the window because we know it's a good window. So put down x min 0, x max 16. You know, I wouldn't need that many seconds. X scale, I just went by ones. For my y, I built in a little extra room at the bottom. So I put negative 200 and up to 1900. And then my graph, I think, is pretty good. So y scale. All right, then part A. Back to my question here. Part A, Mr. Bean thinks that he is wrong. Explain why he's wrong. We could say because it's curved at the top or something, curved at the top. It doesn't go down by the same amount each time is why it's not linear. I know that this distance here is smaller than this distance. Anyway, it doesn't, if it was linear, these would be pretty close to always being the same if they're equally spaced out. So anyway, I'm just going to say because it's curved. So use a regression to write the equation of your model. So I'm deciding right now that it's going to be a quadratic. So I'm going to go back to my calculator. And to go from here, I'm going to go to Stat. And then over here, I have to go to the right to get to Calc. And then before I hit Enter, I'm going to go down to the one that says Quadreg. We haven't used most of these other ones. Someday we will, but anyway, quadratic is a second degree equation, so I'm going to use that. And on the newer calculators, you'll put in the lists. So they're already good for L1 and L2, but if they weren't, you'd use second number 1. So second number 1 would put in L1. If I put in second number 2, it would be L2. Anyway, so my X list is L1, my Y list is L2. I don't need to do anything with the frequency list, but here, store regression equation, I'm going to put in my Y value. So I go vars, then Y vars, then function Y1, and then hit enter. So that's where it's going to store the equation. And now I'll hit enter for calculate. And there's my equation. So negative 16 and 1821. So I'm going to go over here to my paper. I'm going to write y equals negative 16 x squared plus, and there was no x term, there was no b. Remember, b was 0. 1821. So there's my equation. I guess I should have put it over there, but that's all right. And before I go to the calculator, let me show you one. Okay, if you have the other kind of calculator, after you go to Stat, Stat, Calc, Quadreg, and then you hit Enter, it'll take you back to your home screen and you'll see something like this, quad reg. And then what you have to do is put in L1, comma, L2, comma, Y1. Now let me show you how you get that. How do you get L1? You go second, 1. You hit the 1 button. For L2, go second, the 2. Oh, by the way, you do need to hit the comma button. So L1, comma, L2, comma. And then the thing for this is you go to the vars. Vars, then yvars. And then function, and then y1. And then hit enter. And then hit enter one more time, and then it'll spit out the equation for you. It's just the same as the other one then. So that's for the people who have the other kind of calculator. All right, let's go back to our graphing calculator then. So now when I go to y equals, it is in there, even though it's 0.159999. Anyway, you'll see that should fit those dots perfectly. And so the next step then is that I need to predict the height at 7 seconds. So trace. But now notice when I'm on the trace, it says plot 1. So I use the down arrow and then type in 7 and hit enter. And I get 1037. So go back to my paper and write down 1037 feet. Okay, now the next question is, when will it be 1600 feet? Well, it's got to be earlier than 7 seconds, so I'm going to hit the trace and use the get on the line. It said, when will it be 1600? So 14. There it's at 3.6 seconds. There, 1595, so that's 5 seconds. That's 9 seconds. This is closer actually. So I will say at 3.758 seconds. 3.7 approximately, right? 3.758 seconds. Here. Approximately 3.758 seconds. And then it says, when will the glasses smash into the ground? All right. Well, since we did that factoring business, I'm on my trace, I could go down here. We know how to find the 0 by using second calc. So I'll go second calc 0. And it says to the left. There's to the left. So I'll hit enter. There's to the right. I'll hit enter. And then for guess. So it looks like it'll smash into the ground at 10.668 seconds. 10.668 seconds. And what does the y-intercept represent? Well, it represents at time 0, the glasses were, right? They were on his, oops, not glasses, were 1,821 feet above ground, right? That's right when he